Hi, I am Ms. Sindhu. Today, let us discuss about the second chapter of 9th standard chemistry, that is chemical bonding. There are a wide variety of substances in our surroundings, and all these substances are made up of atoms. Atoms combine together to form molecules. How do these atoms combine? And why do these atoms combine? Do all atoms combine in the same manner? And how are these atoms held together in a molecule? All these are discussed in this chapter, chemical bonding. So today in this session, we will discuss about types of chemical bonding. Chemical bonding. The attractive force that holds the atoms together in a molecule is called chemical bonding. Atoms take part in chemical bonding to attain stability, that is by acquiring 8 electrons in the outermost shell. The arrangement of 8 electrons in the outermost shell of an atom is called octet electron configuration. That is, atoms take part in chemical bonding in order to attain stability by acquiring 8 electrons in the outermost shell. And this arrangement of attaining 8 electrons in the outermost shell of an atom is called octet electron configuration. There are mainly two types of chemical bonding. First one is ionic bonding and the second one is covalent bonding. So here we will discuss in detail about these two types of chemical bonding. So first type is ionic bonding. Ionic bonding. Ionic bond is a chemical bond formed by transfer of electrons. In an ionic bond, the ions are held together by electrostatic force of attraction between the oppositely charged ions. Compounds formed by ionic bonding are called ionic compounds. An atom which loses electron becomes positively charged. Such positively charged ions are called cations. An atom which gains electron becomes negatively charged. Such negatively charged ions are called anions. So, in an ionic bond, we have cations which is positively charged and anions which is negatively charged. Now, let us represent few examples of ionic compounds using electron dot diagram. Electron dot diagram. So, in this electron dot diagram, we will be representing only the electrons in the outermost shell, because only the electrons in the outermost shell will take part in chemical reaction. So, the first example we have sodium chloride, that is NaCl, that is a common salt. So, in the case of NaCl, we have two atoms. In an NaCl molecule, we have two atoms, one is sodium and the other one is chlorine. Sodium, the atomic number is 11, so the configuration is 281, and for chlorine it is 17, so the configuration is 287. So here, sodium has got one electron in the outermost shell, so sodium transfers this particular one electron to chlorine in order to attain stability. That is, by transferring one electron to chlorine, chlorine attains stability and it becomes Na+, a cation Na+ with electronic configuration 2,8 and satisfies octet electron configuration. And for chlorine, it has got 7 electrons in the outermost shell. By gaining one more electron, it attains stability. So, it accepts the electron donated by sodium and it becomes Cl- with a configuration 288. Thus, an ionic bond is formed between sodium and chlorine, and we have two ions here, Na+ and Cl-. Na+ is the cation and Cl- is the anion. Now, the second example. Second example, we have magnesium oxide. So, in magnesium oxide molecule, we have one magnesium atom and one oxygen atom. So, magnesium, the atomic number is 12 and for oxygen it is 8. So, the electronic configuration of magnesium is 282 and for oxygen it is 26. That means in the outermost shell of magnesium we have 2 electrons, that is represented here, and in oxygen we have 6 electrons and you can see 6 dots around this oxygen. So, in order to attain stability, magnesium transfers 2 electrons in the outermost shell to oxygen. As a result, both of them will attain stability. Here magnesium transfers 2 electrons, so the charge possessed by magnesium is 2+. An atom which loses electron becomes positively charged. So, here the cation is Mg2+. The second one is oxygen. Oxygen gains 2 electron and it becomes an anion, that is O2-. Since it accepts two electrons, the charge is oxygen O2-. So, this is the case of magnesium oxide. Now, the third example is sodium oxide. Sodium oxide, the electron dot diagram. In sodium oxide, we have 2 sodium atoms and 1 oxygen atom. The electronic configuration for sodium is 2, 8, 1 and for oxygen is 2, 6. You can see that we have 2 sodium atoms here with 1 electron in the outermost shell and oxygen with 6 electrons in the outermost shell. So here both the sodium atoms will donate 1 electron to oxygen. As a result, all of these ions, all of these atoms will attain stability by attaining 8 electrons in the outermost shell. And here the ions are, we have 2 Na plus ions and 1 oxygen ion with 2 minus charge. So this is how ionic bond is formed in sodium oxide. Now let us see the second type of chemical bonding, that is covalent bonding. Covalent bonding. The chemical bond formed as a result of sharing of electrons between the combining atoms is called covalent bonding. A covalent bond formed by sharing one pair of electrons is called a single bond. A covalent bond formed by sharing 2 pairs of electrons is called a double bond. A covalent bond formed by sharing 3 pairs of electrons is called a triple bond. Then compounds formed by covalent bonding are called covalent compounds. So here, let us represent few examples of covalent compounds using electron dot diagram. So the first example is F2 molecule. It's a diatomic molecule. Here we have 2 fluorine atoms. Atomic number for fluorine is 9. So the electronic configuration is, for fluorine it is 2, 7. You can see 7 electrons in the outermost shell of fluorine. We have 2 fluorine atoms here. By gaining 1 more electron, both of them will attain stability. So here 2 fluorine atoms will share a pair of electron and they forms a single covalent bond. They share a pair of electron. You can see a pair of electron in the middle. It shares a pair of electron and forms a single covalent bond and thereby attains stability. So this is how we will represent a single covalent bond. A small line in between 2 fluorine atoms. Then the second one. Second one we have oxygen molecule. In oxygen molecule we have 2 oxygen atoms. And the configuration, electronic configuration for one oxygen atom is 2, 6. Since the atomic number is 8, electronic configuration is 2, 6. So there are 6 electrons around each oxygen atom. In order to attain stability, they should gain 2 more electrons. So both these oxygen atoms will share 2 pairs of electrons. Okay, and then attains stability. So here a double bond is formed. A covalent bond formed by sharing 2 pairs of electron is a double covalent bond. So here the bond is a double bond. In between 2 oxygen atoms you can see two lines that represents a double bond. Now the third example, that is nitrogen molecule. Here we have 2 nitrogen atoms. For nitrogen the atomic number is 7. So the configuration is 2, 5. Around each nitrogen atom we have 5 electrons. So in order to attain stability, each nitrogen atom should get 3 more electrons. So these 2 nitrogen atoms will share 3 pairs of electrons and attains stability. So the covalent bond formed by sharing 3 pairs of electrons is a triple bond. So how to represent a triple bond? That is, between 2 nitrogen atoms you can see 3 lines. This represents a triple bond. Next we have hydrogen chloride. So this is a covalent bond formed between 2 different atoms, that is hydrogen and chlorine. Hydrogen, the atomic number is 1 and it has got only one single shell around hydrogen and that particular electron is present in that single shell. And the maximum number of electrons that can be accommodated in the first shell is 2. So in the case of hydrogen, instead of octet configuration, it satisfies duplet. That is 2 electrons is enough for hydrogen to get stability. In the case of chlorine, the configuration is 2, 8, 7. By getting 1 more electron, chlorine attains stability. So here a pair of electrons is shared between hydrogen and chlorine and a single covalent bond is formed between hydrogen and chlorine. Then the last example, we have carbon tetrachloride. So in carbon tetrachloride, we have 1 carbon atom and 4 chlorine atoms. And the electronic configuration for carbon is 2, 4. And for chlorine is, we have 2, 8, 7. So there are 4 electrons in the outermost shell of carbon and 7 electrons in the outermost shell of chlorine. So in order to attain stability, carbon should get 4 more electrons and chlorine need only 1 electron. So here carbon forms a single covalent bond with each chlorine atom. You can see that carbon shares a pair of electron between each chlorine atom and forms a single covalent bond. So this is how a covalent bond is formed. So let us conclude this session. So today we studied about chemical bonding. Chemical bonding is an attractive force that holds the atoms together in a molecule. Then there are mainly two types of chemical bonding. One is ionic bonding, which is formed by transfer of electrons. The other one is covalent bonding, which is formed by sharing of electrons. So let me wind up the session. Thank you.